Algebra 2, Chapter 13.2, Exercise 1 through 10. In this section, we're working on exponential growth functions. And I'm going to do mostly odd number problems here. I'm going to make an exception here in this case, though. Describe the effect of each transformation of parent function, graph the parent function and this transformation, and determine the domain, range, and y-intercept of each function. So this goes back to, we have 2 to the x, f of x equals 2x power, and what that looks like. And we did this in our introductory video. If we have x, f of x, we have x equals -2. We have 1/4 as an output because it's 1 over 2 squared. For -1, we have 1/2 as an output. For 0, which is where we have our y-intercept, we have 1. For input of 1, we have an output of 2. For input of 2, we have an output of 2 squared, which is 4. And then 3, 8, is the square of 3, 8. So we know that far. And so f of x equals 2x, we have these on the x-axis, these are going up by 2, and also on the y-axis and x-axis. So we have 0, 1. As we go to the left, we have -1, 1. -1 is 1/2. -2 is 1/4. And so we're looking like this. We have input of 1. We have an output of 2. We have an input of 2 and an output of 4. We have an input of 3. We have an output of 8. And so the graph is what this looks like. Okay, that's pretty good. And as far as the other one, I'm going to go make a red one here for the transformation. What we're doing for 2, we have this thing outside. That's our initial value. And so what we're going to do for this one, we're going to have x. I'm going to write right next to it g of x. Basically, what we're doing for this one is we're taking all these values for f of x and we're multiplying them by 2. So for g of x, we have 1/4 times 2, which is 1/2. We have 1/2 times 2, which is 1. We have 1 times 2, which is 2. 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is 16. And so here we have our y-intercept at 0, 2. Then we go to -1, 1. We have -2, 1/2. And then as we go to the right here, we have an input of 1, we have an output of 4. So that's going to be right here. Input of 2, output of 8. And so we'll look like this. Okay, that's not such a bad drawing. Okay, and its transformation to determine the domain, range, and so forth. So domain for, let's say for f of x, domain of all real numbers. going to just give me a minute. Okay. Range we're going to be going from 0, but not greater than 0, to less than 30. And this is for f of x and g of x. Okay. For the domain range for f of x and g of x, y-intercept we're going for where x equals 0. So it's 1 for f of x, and it's going to be 2 for g of x. So really that's going to be it. Let's go on to problem 3. Next on the problem. We have 2 to the power x and g of x equals 2 times 20x plus 2. So what that is, I'm going to do similar to what we did last time. I'm going to put x, f of x, right next to it. I'm going to put g of x. So x is negative 2, we have 1 4, same as we had last time. Negative 1, we have 1 half. 0, 1, 1, 2, 2, 4, 4, 3, 3, 8. Okay. Now, for this one here, what this does is it does the same thing, but it shifts everything. So what does this x plus 2 do? There we have this f of x equals a times our base x minus 8 plus k. What this is going to do, this plus 2 will shift to 2 units. X plus moves to the left, so 2 units left. So what that is going to do, let me just graph the first one. The same as we did with 0, 1, negative 1, 1 half, negative 2, 1 4, 1, 2, 2, 4, 3, 8. And so this is what it looks like. So what we're doing is we're going to shift 2 to the left. So what I'm going to do is take another graph and we'll just draw it right on top of it like this. Just drawing this red one right on top. Okay, now I'm going to take this red one here and shift it to the left. 1, 2, right here. There you go. So what it is, I'm going to just write this below. Okay, what we do is we have 0, 4. So everything just shifts over 1. Where this is 4, we go 1 to the right. And then have 8. 2 is going to be 16. And 3 is going to be doubling every time you go to the right. As you go to the left, this 4, we have 2 here, and 1 here, that negative 2. So it's going to look this. Now, let's go ahead for f of x and g of x. The is all real numbers. Range. Again, we have our horizontal asymptote of y equals 0. So greater than 0 to less than infinity. That's for domain and range, each of these functions. Now, what is going to be our y-intercept for f of x y-intercept is going to be equal to 1 for g of x that we shifted y-intercept equals 4. So really that's it. Okay, now normally I would do number 5, but what I'm going to do is, and this 5 is very similar to problem 1 that we did earlier, but only for base 10. So I'm going to go ahead and work out 6 in this set, because there's a little more complexity involved here. So the first thing I'm going to do is graph this 10 to the x, and I'm going to make these over to the left. I'm going to put x, f of x, and then g of x. So I'm going to go with the same as I did earlier, negative 2, negative 1, 0, 1, 2. So if we plug in, if we have 10 to the negative 1 power, that's going to be 1 over 10 squared, or 1/100. If we plug in negative 1, we get 1/10. If we plug in 0, we get 1, because 10 to the power 1. If we plug in 1, we get 10. If we plug in 2, we get 10 to the power 2, which is 100. So what that looks like is very much like problem number 1, but much steeper. So we have 0, 1, that's our y-intercept, and we have negative 1, 1/10, negative 2, 100. At 1, we have 10. At 2, we have 100. So it's very steep curve here. Okay, that'll suffice. Okay. If we have negative 4 times 10 to the x power, what we're going to do is take f of x times negative 4. So we get, instead of 100, we get negative 400. Which is going to be negative 250 is 25th. We have negative 4/10, which is going to be negative 2/5. We're going to have negative 4 here. We're going to have negative 40. We're going to have negative 400. So this is what it's going to look like. Our, wait a second. That is a negative 4. Okay. So we have 0, negative 4. We have negative 1, negative 4/10. It's going to look something like this. We have negative 400. Then we got negative 40 down here. So it's going to be look like this. Again. It's hard to draw this one there. You have trouble getting it to go to the right. This is going to the right, this is slightly. So it looks something like this. It's stretched by a factor of 4. So we get minimum. Okay, for f of x and g of x domain is equal to all the numbers. Our domain for f of x domain is equal to range, range equals 0, greater than 0, less than 3. And for g of x, we're coming from negative infinity going up towards 0. So we're going to have negative infinity up to but now including 0. And our for f of x, y-intercept, and so x equals 0 is 1. For g of x, y-intercept equals negative 4. So that would be number 6 worked out. This one is next on the problem, which is 7. What we're doing is we're taking this and shifting it over. So I'm going to draw a couple separate tables for each one. I think it might work out better this way. So we're going to have x, f of x. So we have negative 2, negative 1, 0, 1, 2. So we have 1, 100. 110, 1, and 100. So it's going to look like this. 0, 1, negative 1, 110, negative 2, 100, 1, 10. It's like the first part of the curve is not so bad for the last. It just gets hard to stick with it. That's going to be about as good as I can do. Okay. What you're doing with this one here, as we did in that 5, we're going to shift it x minus 2, and then we're going to take this curve and that more or less on the other one. We take this and we shift it to the right 2 units. And so yeah, that right here. So what we have for this is we make a table. X, g of x. Now we move to the right here, so our y-intercept is going to be right here. That we're going to have 0. We're going to have 1, 100. And so it's just like taking negative 2 and moving it to the right. 1 is going to be 110. 2 is going to be like the y-intercept we have originally. So for 2, we're going to have 1, or 3, we have 10, and 4, we're going to have 100. So what is that going to look like? Well, just the way we draw it right here. 2, 1, 3, 10. Yeah, it's hard to see, but that's, I guess, for technicality, we need to shade more of the light. So that is going to be it. Now, for f of x and g of x, the main all real numbers. Range greater than 0, less than infinity. For f of x, y-intercept is equal to 1, for g of x, y-intercept equals 100. Again, the y-intercept is where x equals 0. Okay. Now, 9 and 10 are different. So we have described the graph of g of x equals 2 to the power x minus 3 minus 4. So what we have is, remember that form I showed earlier in this video, in file 1 of f of x equals a times the base times power x minus 8 plus k. So what does this do? We have the same base in each case. So g of x is f of x is one of the transformations, x minus 3. So translated, 3 units to the right, and it's minus 4, and translated 4 units down. So let's go ahead and put this. I want to show you the calculator here quickly. So we have 2 to the power of x, which is the blue one. And then we have 2 to the power of x minus 3. Okay. Now there's another part of that function, which was shifted 4 units down. We'll take this minus 4, and now we're going to downshift that red one 4 units. So 3 units to the right, 4 units down. It doesn't look like it's 3 to the right because it looks like it's more than 3, but moving the thing down, if you remember the one before we shifted, it was 3 units exactly. So anyway, that's it. I want you to get number 10. It's a similar type of problem, but with a base 10 function. I don't think these are too hard. Good luck, and thanks for viewing.